Welcome to All Academic Channel, where questions matter more than answers. Right now, as you are watching this video, invisible waves are moving through the air around you. These waves carry messages, videos, music, and entire conversations. Every second, billions of devices around the world are connected through them. But have you ever stopped and asked yourself a simple question? How does Wi-Fi actually work? How can information travel through the air without any wires? How does your phone communicate with a router in another room? And is the technology behind Wi-Fi really safe? In this video, we explore the science behind Wi-Fi, from its history to the physics that makes it possible, how modern wireless networks function, and what scientific research says about its safety. To understand Wi-Fi, we first need to understand electromagnetic waves. Electromagnetic waves are a fundamental part of physics. They are oscillating electric and magnetic fields that move through space and carry energy. These waves form the electromagnetic spectrum, which includes radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. The only difference between these waves is their frequency and energy. Wi-Fi belongs to the category of radio waves, specifically in the microwave range of the electromagnetic spectrum. Most Wi-Fi networks operate at frequencies around 2.4 GHz, 5 GHz, and more recently 6 GHz. A gigahertz means 1 billion oscillations per second. That means Wi-Fi signals are electromagnetic waves oscillating billions of times every second as they travel through space. The scientific foundation for electromagnetic waves was established in the 1860s by the Scottish physicist James Clerk Maxwell. Maxwell's equations predicted that electric and magnetic fields could propagate through space as waves traveling at the speed of light. Later, in 1888, the German physicist Heinrich Hertz experimentally confirmed the existence of these electromagnetic waves. Hertz demonstrated that invisible waves could travel through air and carry energy. This discovery eventually led to radio communication, television broadcasting, radar systems, and many decades later, wireless internet. But Wi-Fi itself is actually a relatively recent invention. The modern development of Wi-Fi began in the late 20th century. In 1997, the Institute of Electrical and Electronics Engineers, known as IEEE, introduced the first wireless networking standard called IEEE 802.11. This standard defined how devices could communicate wirelessly over radio frequencies. The original system supported data speeds of only about 2 megabits per second, which was extremely slow compared to modern networks. In 1999, the Wi-Fi Alliance was created to ensure compatibility between different wireless devices. Around this time, the term Wi-Fi became widely used as a consumer-friendly name for wireless networking technology. Since then, Wi-Fi has evolved dramatically. New standards, such as 802.11b, 802.11 grams, 802.11n, 802.11ac, and most recently Wi-Fi 6 and Wi-Fi 6E have increased wireless speeds by thousands of times. Today, modern Wi-Fi systems can theoretically reach speeds above 9 gigabits per second. But how exactly does Wi-Fi send information through the air? At its core, Wi-Fi works by converting digital information into radio signals. Your internet router is connected to the internet through a physical cable, usually fiber optic or broadband. The router receives digital data from the internet, which is encoded in binary form, zeros and ones. The router then converts this digital information into radio waves using a process called modulation. Modulation is a technique that allows information to be embedded into a carrier wave. The carrier wave is the radio signal, and the data is encoded by slightly modifying properties of that wave, such as its amplitude, frequency, or phase. Modern Wi-Fi uses advanced modulation techniques, such as orthogonal frequency division, multiplexing. It's often abbreviated as OFDM. OFDM works by splitting a large data stream into many smaller streams that are transmitted simultaneously across multiple closely spaced frequencies. This approach improves efficiency, increases speed, and helps reduce signal interference. Once the signal is transmitted, the radio waves spread outward from the router. Your smartphone, laptop, or tablet contains a wireless adapter and antenna that can detect these radio signals. The device receives the electromagnetic wave and performs a reverse process called demodulation. Demodulation converts the radio signal back into digital information that the device can process and display. So in simple terms, Wi-Fi works by encoding digital data into radio waves, transmitting those waves through space, and then decoding them back into usable information. But there are challenges in this process. Radio signals weaken as they travel through space. Walls, metal surfaces, and even water can absorb or scatter Wi-Fi signals. Because the human body contains a large amount of water, it can absorb small amounts of microwave energy. However, the power levels used in Wi-Fi devices are extremely low. A typical Wi-Fi router operates at less than 1 watt of power. For comparison, a microwave oven operates at around 700 to 1000 watts, hundreds of times stronger. This leads to a common question: is Wi-Fi dangerous? Wi-Fi signals belong to the category of non-ionizing radiation. Non-ionizing radiation does not carry enough energy to remove electrons from atoms or damage DNA. According to the World Health Organization and the International Commission on Non-ionizing Radiation Protection, exposure from Wi-Fi devices is far below established safety limits. Large reviews of scientific literature have not found consistent evidence that level radio frequency exposure from Wi-Fi causes adverse health effects when within recommended exposure levels. However, scientific research continues, and regulatory agencies continue monitoring long-term exposure. Now let us explore why modern Wi-Fi has become so fast and reliable. One key technology is called MIMO, which stands for multiple input, multiple output. Instead of using one antenna to transmit data, modern routers use multiple antennas to send several data streams simultaneously. This dramatically increases the total amount of data that can be transmitted at once. Another innovation is beamforming. Traditional wireless signals spread in all directions equally. Beamforming allows routers to focus the signal toward a specific device, improving signal strength and reducing interference. Another reason Wi-Fi speeds improved is the use of wider frequency channels. By using larger portions of the radio spectrum, routers can transmit more data simultaneously. However, wireless networks also face interference. Many devices share similar frequency ranges, including Bluetooth devices, baby monitors, and even microwave ovens. For example, microwave ovens operate near 2.45 GHz, which overlaps with the 2.4 GHz Wi-Fi band. This is why many modern routers also operate in the 5 GHz or 6 GHz bands, where there is less congestion and higher data capacity. Today, Wi-Fi is a critical part of modern infrastructure. Wireless internet enables remote work, online education, telemedicine, global communication, and the rapid exchange of information. In many ways, Wi-Fi represents the combination of fundamental physics, electrical engineering, and digital communication theory. From Maxwell's equations in the 19th century to global wireless networks in the 21st century, the science behind Wi-Fi demonstrates how theoretical discoveries can transform everyday life. The invisible electromagnetic waves surrounding us every day are not magic. They are the direct result of scientific knowledge, engineering innovation, and decades of technological progress. And the next time you connect your phone to a wireless network or stream a video instantly from across the world, remember that you are experiencing the practical power of physics. Thank you for watching this video. If you enjoyed this video, explore our Science in Daily Life playlist, where we explain the science behind the technologies you use every day. Don't forget to like, subscribe, and turn on notifications so you never miss a question that matters.